Hey everybody, thanks for joining us for tonight's Tech Talk. If everyone could unmute really quickly and give Eric a nice warm round of applause, please.
Yeah.
Yes. Thanks again for coming, and Eric, over to you when you're ready.
Thanks, Sam. Before I get started, I want to thank SingleSprout for sponsoring this talk. So since the advent of code-generating AI, such as GitHub Copilot, there's been serious concern as to whether this will spell an end to the software engineering industry as we know it. Just as factory workers in the second industrial revolution were displaced in favor of machines, so might software engineering jobs be replaced by AI programmers. While there are many valid reasons for concern, I'd like to make a case for why this might not be the end for software developers, and more specifically, how we can keep our industry knowledge relevant by engaging in test-driven development. So at this point, you may still be a little bit skeptical as to whether AI is going to be a serious threat for developer jobs. And I think what that comes down to is just how easy it is to underestimate how rapidly AI is improving. I'd like to take a brief history here of some of the recent advances in AI to demonstrate how they consistently outperform our expectations. So probably the first landmark for AI was the victory of Deep Blue against world chess champion Garry Kasparov in 1996. So this was really groundbreaking because while it's a very narrow analytical field, the AI did beat the best human in the world. Now, fast forward 20 years, AlphaGo, developed by OpenAI, defeats world Go champion Lee Sedol. So what's the difference? What's the big deal, one board game or another? Well, it turns out Go has a lot more potential board states. But beyond that, the strategy involved is not so much analytical as intuitive, to the point where the vast majority of experts at the time believed this was an impossible feat. AI is currently, in some limited contexts, capable of passing the Turing test. Couple images here. Raise your hand if you think the one on the right is fake. Now, raise your hand if you think the one on the left is fake. Okay, the left one is fake. I can't tell the difference. They both look like real people to me. So it can generate lifelike images. AI is better than humans at face recognition. Here's a tool called DALL-E. It takes in an input of natural language, just like a sentence, and will generate unique images representing what that sentence describes. Here's an example. The text prompt is a living room with 2 white armchairs and a painting of the Colosseum. The painting is mounted above a modern fireplace. So we can see that in these images, the AI has generated a unique artistic representation of this object, the Colosseum, is placed it in physical space in relation to other objects. And it really seems like on a certain deep, meaningful level, this AI understands what these words mean. So this is built upon GPT-3. GPT-3 is a large language model. And it is capable of generating poetry and articles that, according to a study, were found to be indistinguishable from poetry and articles written by humans. So in this limited context, it is passing the Turing test. You can see, I just want to demonstrate here real quick just how quickly this is evolving though, because if you look on the left, there's some poetry generated in 2019 by GPT-2. That's the precursor to GPT-3. Doesn't really make any sense. There's words, but they don't seem to have any meaning. Compare that to what you see on the right, generated by GPT-3. It's chilling. So this is pretty significant, but how does it do with something a little bit more concrete? Poetry is pretty abstract. How could it handle something like coding? Well, that's what Codex is for. And Codex is the basis upon which GitHub Copilot was built. So this is an example of how GitHub Copilot works. Basically, you type in a natural language description of what you want your function to do. That's that comment at the top. You may alternatively write the class definition, just like the name of the function and the inputs and outputs, and it will generate a valid solution to that question. Here's another example. This is alpha code. This is from an article that came out just 4 days ago. Alpha code is capable of competing in coding competitions against professional coding competitors slightly above the average. So everything you see here is the input prompt that was given to both alpha code and the competitors. And here is a solution that alpha code generated. And this is a problem that alpha code had never seen before. It generated a unique solution to a problem it had never encountered before. So this is obviously very impressive, but it still does have some limitations. For example, GitHub Copilot will often produce, sometimes will produce code that is nonsensical, that does not work. It will often produce code that does work, but is not well optimized. So these are limitations, but it's important to remember that these limitations are likely temporary, because if you consider the level of improvement from GPT-2 to GPT-3, consider how much of an improvement GPT-4 will be, which comes out sometime later next year. So, like it or not, it seems that AI programming is here to stay. So how is this going to affect developer jobs? Well, one thing we can explore is what it's going to be like to work alongside an AI programmer. And the process kind of goes like this. First, you think about what you want your code to accomplish. So this is a broad conceptual understanding. And when you have that, you can describe it in natural language. So that's the comment at the top. Find the largest number in a nested array. The code is generated automatically. Now, the next step is incredibly important. This is to understand the code that has been generated, because occasionally this code is not going to be effective, and it may have unintended side effects. So at this point, we can examine the code and consider edge cases, side effects, ways this will affect things that we had not previously considered. And at that point, we can refactor the code ourselves, or we can provide that feedback to the AI programmer, and it will generate the code for you. So as a whole, I would summarize this process as we want to start conceptual, then consider all the details, and the code itself is an afterthought. Now, this is actually the same thing as test-driven development. So what is test-driven development? Well, first we have to ask, what are tests? Tests are just functions that confirm that the code behaves the way that you want it to, and that there are no unintended side effects. So essentially, they're just functions that can test, given a certain input, we will expect a certain output from this function. And that can also test with end-to-end testing and integration testing, we can test how these functions relate to each other. So then test-driven development is just the process of first starting conceptually what you want to accomplish. Then you have to consider all of the details, all the side effects and edge cases, and then finally write tests that confirm that expected behavior. And again, the code itself is an afterthought. So this process is maximally declarative. We're not really worried about how we're implementing the code, just what it does. So you may be asking yourself at this point, is this going to replace developer jobs? Well, there's certainly no doubt that it will increase productivity dramatically, which will reduce the number of programmers necessary to accomplish the same task we achieve today. There's a financial motivation here for companies to hire fewer developers. After all, what company is going to hire 200 employees when it can instead hire 100 and have an AI programmer accomplish the same tasks faster? But it's a little bit more complicated than that. Think about the impact that this is going to have in startup culture. It's definitely going to speed up time to launch. It's going to increase the sophistication of the products being developed by startups. What this is going to do is it's going to drive innovation, meaning that existing companies are going to want to hire more employees, more developers, in order to keep their products relevant. Essentially, the more productivity just translates into more features, more time to fill out the features in your backlog. An example of how this has always been the case, think back 20 years ago, what was the web like? HTML, CSS. Yeah, and today we've got all sorts of stuff, responsivity, breakpoints, single page applications, sophisticated data interpretation in the backend to give you a customized experience. So it's pretty clear that the drive for innovation is still going pretty strong, and that further improvements to productivity are just likely going to increase that. But you may be asking yourself, okay, but are they going to hire fewer employees? Excuse me, if you may be at this point wondering if they're going to pay developers less because they can hire people with less technical expertise. And currently, I believe the answer is no. Because being a seasoned engineer allows you to make informed inquiries to the AI, which will greatly increase your efficiency using it. You have to be thinking about system architecture, abstract conceptualization of the whole product, but even going down to the fine details of how that product is implemented. Because again, it remains important for you to fully understand the code that's being implemented. And as we talked about, this is for code maintainability and scalability, for efficiency, and also for security reasons. So it seems that right now our jobs are safe. In the future, who's to say? I think there's really no overestimating what AI is capable of. And with that, that's all the time I have for you today. So thank you so much, and please let me know if you have any questions.
Thank you so much, Eric. Could everybody unmute real quick? Give Eric a round of applause for that awesome tech talk. Woo! Yeah, let's open up the floor if there are any questions. Go ahead and use that raise hand feature. Dimitri, go for it.
Thank you, Eric, for your great informative talk. And I do have a question regarding test-driven development, specifically at this point, looking at how fast artificial intellect grows, comparing GPT-3 to GPT-2, and that it's able to defeat intellect of the world champion right now. Do you think people are even able to test, or they can bring into coding something more than what artificial intellect already does? Does it even make sense to test what AI does at this point?
Yeah, great question, Dimitri. I think definitely. And the reason for this is because while AI is very impressive and can do things we can't, it's also prone to errors. And the places it's going to mess up are in different places than humans are. So it remains extremely important to have an approach where you're testing the code to make sure that there aren't going to be breaking changes later down the line. This is what's called technological debt, where your code works now, but you don't know if it will always work, and it's going to be a big hassle to fix it later down.
Thank you.
Awesome question, Dimitri. Great answer, Eric. Thanks again for the amazing talk. We're going to wrap it there for tonight.